Hi guys, welcome to the video, and in this lesson we're going to be looking at the reactivities of group 1 and group 7 elements. As we go down group 1, the elements get more reactive. Each element in group 1 wants to lose this outer shell electron to form a +1 ion, and it will do this by reacting with a non-metal to form an ionic bond. But for your exam, you'll need to explain why potassium is a lot more reactive than lithium. This can be observed if you add potassium to water, and the potassium will usually catch on fire, whereas lithium will produce a lot of bubbles. So let's start to explain why the reactivity changes as we go down the group. Well, first of all, you guys should all see that as we go down group 1, we're increasing the number of electron shells. And as we're increasing the number of electron shells, the outer shell electron is becoming further and further from the nucleus. As the outer shell electron is becoming further and further from the nucleus, the attraction between the nucleus and the outer shell has weakened. This means that the outer shell electron of potassium is more easily lost than the outer shell electron of lithium. But what about the group 7 elements? Group 7 elements, they all want to gain 1 electron to have a complete outer shell. When the group 7 elements gain an electron, they form a -1 ion. And if you remember from our previous video, we said that as you go down group 7, the elements get less reactive. And again, you guys need to explain why this reactivity changes as we go down the group. Well, again, as we go down group 7, we are increasing the number of shells. For example, chlorine has more shells of electrons than fluorine. Bromine would have more shells than chlorine. But as we increase the number of shells, the outer shell is further from the nucleus. And this means that the attraction between the nucleus and the outer shell is getting weaker. This means it's harder for chlorine to accept an electron compared to fluorine. The force of attraction from the nucleus and the outer shell is much stronger in fluorine, so it can easily gain an electron. But as we go down the group, that attraction is getting weaker. Chlorine cannot accept the electron in its outer shell as easily as fluorine can. Okay guys, thanks for tuning in. Stay in touch for another video.